Welcome to this Forge College Explainer. So let's just be completely honest for a second. If there is one thing that absolutely keeps developers wide awake at night or, completely ruins a perfectly good weekend, it's pushing code to a live, immutable blockchain environment, right? Today, we are firmly putting an end to the absolute disaster that is cowboy coding on Solana. Instead, we're going to look at some deployment checklist schematics. Think of these as your ultimate engineering blueprint. We're literally going to ink out a process that brings order to the chaos. Okay, so here's the master schematic for today's explainer. We'll start with 1, welcome to the blueprint. Then 2, anatomy of a checklist. Next is 3, automating the blueprint, followed by 4, the release workflow. And finally, 5, the final inspection. Let's just dive right in. Welcome to the blueprint. Now we're picking up exactly where we left off in our previous lesson, assembling the capstone decision framework. You've already made all those tough choices about RPC capacity and fee pairs. Now, it is time to translate those high-level decisions into a very concrete plan. So what exactly is this tool we're talking about? Well, a deployment checklist is a structured set of verifications, assignments, and configuration gates that you absolutely must complete before deploying to a Solana cluster. And here's the crucial part. This is not just some boring administrative paperwork that you fill out to make management happy and then stuff into a dusty drawer somewhere. No way. It is a meticulously designed disaster avoidance mechanism. It's really a living, breathing set of gates that creates this perfect, repeatable handoff between your engineering, security, and ops teams. All right, moving to section 2, anatomy of a checklist. Let's dissect a checklist entry to see exactly how it works under the hood, taking these kind of abstract concepts and breaking them down into practical engineering components. For this blueprint to actually work, every single item on your checklist needs to have these 4 required attributes. First, a description of what we're actually checking. Second, an owner who is directly responsible for it. Third, a verification method to prove it's been satisfied. And fourth, and this is key, acceptance criteria. Those are the exact numeric thresholds that dictate a clear pass or fail. Because look, if you just write down, check the RPC node, you're practically begging for trouble. But if you require the release engineer to verify RPC latency is strictly under 200 milliseconds, boom, you've eliminated all the ambiguity. I like to think of this matrix of responsibilities like a highly precise assembly line. Configuration gates, which ensure your endpoints are correct, those are owned by the release engineer. The engineering manager takes the roles category to confirm the upgrade authority. QA handles the on-chain tests, and ops confirms the monitors are actually firing. When the deployment pressure is really on and tensions are high, this strict categorization means there is absolutely zero finger pointing. Everybody knows their job. Section 3, automating the blueprint. Now, you might be sitting there wondering, how on earth do we enforce all these rules without some human slowing down our rapid development cycles? Good question. The answer is automation. By just dropping a super simple TypeScript validator right into your CI/CD pipeline, you can enforce a really powerful core logic rule. If a verification is marked as automated, it absolutely must have measurable acceptance criteria, period. It inspects your JSON or YAML metadata without ever having to touch live wallets or network secrets. Missing an owner, the script just throws a non-zero exit code and blocks the release instantly. It is an incredibly elegant, completely frictionless security gate. Ultimately, it's all about balancing speed with safety. Everything mechanical, like, pinging endpoints or checking file structures, that should all be handed off to automated verification for rapid script-based processing. Keep it moving fast. But for those high-stakes, irreversible decisions, like maybe approving an emergency revert or modifying an upgrade authority, that is where you pause for manual verification. Human judgment and detailed inspection are just irreplaceable there. Okay, section 4, the release workflow. Let's actually trace the chronological path your code takes as it moves from your laptop all the way through to production. Because deploying is never just a single button press, right? It's a journey. In the prepare stage, you assign your owners and document endpoints. Next up, in validate, your automated TypeScript scripts and dry runs do their magic. Then we finally hit deploy. And since we're operating on Solana, you are definitely going to want to use a staged or canary rollout here. Next is monitor, where you keep your eyes glued to those real-time dashboards. And finally, finalize, or if the alarms suddenly start blaring, confidently execute the rollback steps that you already documented in your handy checklist. Let's zoom in on that monitor step for a second. Your site reliability engineer needs 2 very distinct windows. The fast window covers those crucial first 10 to 30 minutes. This is absolutely critical on Solana, where changes to account layouts or fee behavior manifest almost instantly. If error rates spike here, you halt immediately. But you also have to maintain a medium window over the next 24 hours to catch those insidious, slow-creeping, usage-driven bugs. Your checklist ensures there's no doubt about exactly who is watching the glass during both of these windows.
And finally, Section 5, the final inspection. We've built out our blueprint, we've integrated our safeguards, so let's zoom out a bit and remember exactly why we do all of this.
This quote really hits the nail on the head. Good deployment checklists convert tacit knowledge into explicit, auditable steps. Tacit knowledge is basically that unwritten, highly localized wisdom floating around inside your senior developer's head. You know, the exact knowledge that magically vanishes when they're off-grid camping during a massive mainnet crisis. By converting all of that into a machine-readable, auditable schema, you completely transform a panic-inducing deployment into a predictable, entirely boring, which is a good thing, and highly controlled engineering process. So, as we wrap up this explainer, I want to leave you with a quick question to chew on. What hidden, unwritten risks are your current deployments secretly relying on right now? Today is the perfect day to start mapping those out on paper. Thank you so much for joining me for this Forge College explainer. I really hope you found these blueprints as fascinating as I do. Be sure to visit forge.college to learn more about this subject and a ton of other fantastic Web3 topics. See you in the next one.